The NASA plan holds that in the 2030s, humans will reach Mars. The question of what comes next is driving steady progress in research on terraforming. Transforming Mars will be a tremendous undertaking. Numerous difficulties are expected, but human beings will overcome those difficulties and turn Mars into a new Earth. Chris McKay has a 100-year plan for terraforming Mars. It's the new frontier in space development. The Terraforming of Mars, as conceptualized by Chris McKay of NASA. Humans will finally reach Mars in the year 2035. After a voyage taking half a year, the great day has arrived. The crew of 6 includes geologists and biologists. They begin by conducting a detailed survey of the Mars environment. That will provide information hitherto unobtainable by unmanned space probes. With the landing craft as a base of operations, the astronauts will also start preparations to build a facility for long-term habitation. The temperature on Mars ranges from -130 degrees to +20 degrees Celsius, depending on season and location. The average is an extremely low -55 degrees. There is almost no oxygen. The atmosphere is extremely thin, just 1/160th of Earth's. The sun's harmful UV rays beat down on the Martian surface without mercy. Without a protective spacesuit, human activity on the surface would be impossible. Fortunately, the gravity on Mars is only 1/3 of Earth's. That makes wearing these 100-kilogram spacesuits a little easier. A brutal environment, inimical to human life. What would it take to turn this arid red planet into a hospitable, Earth-like place of blue and green? An atmosphere, for one thing. Earth's thick atmosphere absorbs the sun's UV rays, protecting life. Another is water. Earth's abundant waters foster diverse living organisms. A thick atmosphere and plentiful waters. That's how it has to start. The terraforming of Mars. The concept of terraforming has been seen in science fiction since the 1930s. Such works describe the dream of humankind to transform other planets into Earth-like environments that we can migrate to. The first scientific proposals for terraforming were elaborated by Carl Sagan, NASA's leading advisor on planetary exploration. In 1961, Sagan published an article in the journal Science concerning the terraforming of Earth's closest neighbor, Venus. At the time, Venus was thought to be enveloped in an atmosphere of water vapor and carbon dioxide, and to have a surface temperature of 100 degrees Celsius. Sagan argued that if this atmosphere could be seeded with photosynthesizing bacteria, they would produce oxygen, which would enable terraforming to take place. However, when Mariner 5 and other space probes reached Venus, they discovered a more hostile environment. The surface temperature is 460 degrees. There's hardly any water, but there is rain. Unfortunately, it's sulfuric acid. It was realized that transforming Venus involved formidable technological difficulties. But the times led people to think hard about terraforming. One country after another developed nuclear weapons. If there were to be a nuclear war, scientists speculated that the consequences could be disastrous. Other issues included irreversible environmental collapse, uncontrollable population growth. There was even concern that Earth might become entirely uninhabitable. That was when terraforming attracted new interest. There were even scientists who began seriously advocating migration to another planet if humanity hoped to survive and flourish. A top candidate was Mars. Mars is only about half the size of Earth, but similar to Earth in that it has 4 seasons and a roughly 24-hour revolution on its axis. In 1976, the Viking 1 space probe made the first ever landing on Mars. It sent back detailed images of the Martian surface. The bleak landscape reminded viewers of Earth's deserts. However, as exploration proceeded, it became clear that Mars also possessed many of the conditions necessary for terraforming. Both the northern and the southern poles of the red planet are covered by masses of a white substance. That substance turned out to be a layer of solid carbon dioxide, dry ice. At their smallest seasonal extent, the 2 polar caps together cover 2.4 million square kilometers. That's 6 times the entire land area of California. If those dry ice coverings could be vaporized, a vast carbon dioxide atmosphere would be created. Life forms would be protected from the sun's UV radiation. In 2008, the Phoenix Mars lander reached a site near the North Pole. its robotic arm dug into the Martian surface. A few centimeters below the surface, it discovered something extremely important. Water ice. Water exists as ice under the Martian ground. Then, in 2012, the Curiosity rover landed on Mars. It has discovered evidence of the historical existence of water on Mars. A deposit of pebbles, each one just a few centimeters across. It looks like the remains of a river, whose flow had once carried these pebbles along, wearing them down. Other space probes orbiting Mars spotted various features suggesting that water had once flowed there. The conclusion? A large volume of water had formerly flowed on Mars, but that due to such factors as climate change, it had frozen and was now locked up underground. Dry ice and water ice. These could be used to create an atmosphere and fresh water. Scientists were intrigued. One of them, a well-known proponent of manned Mars exploration and settlement, is Robert Zubrin. He says the method might be very simple.
On Mars, there's places where there's water ice and continent-sized regions. Mars has got carbon dioxide. The first step of terraforming Mars is warming the planet.
But how precisely are we to warm up Mars? Many ideas have been proposed. One method stands out. Use gases that produce a greenhouse effect. The lead author of that proposal was Chris McKay.
We estimate that if we were to produce greenhouse gases on Mars, it could be warm, almost as warm as Earth, say warm at the freezing point where ice can melt.
Some of the same greenhouse gases that have been blamed for global warming. They could also be the key to warming Mars. In Chris McKay's concept, the first step would be to build a factory on Mars that could pump carbon dioxide and other greenhouse gases into the Martian atmosphere. The sun's rays warm the surface, which would re-radiate infrared rays upward. Some of this thermal radiation is absorbed by the greenhouse gases, causing heat to build up. Rising temperatures vaporize the dry ice at the poles, further increasing the CO2 in the atmosphere. As the huge volume of ice under the Martian surface also melts, water will be produced. This early theory, relying on carbon dioxide, raised a serious question. Producing an environment capable of sustaining life would take thousands of years. It was a question of time. McKay's group at NASA continued to study the problem and came up with a method for dramatically shortening the time period. It would use octafluoropropane, a fluorocarbon greenhouse gas. Using this method, terraforming would take just 100 years. The proposal to use C3F8 was made by one of Chris McKay's co-researchers, Margarita Marinova.
These are the super greenhouse gases that we have looked at. One of these super greenhouse gases has a warming potential about 24,000 times as strong as CO2. That makes it a great candidate. That means that you need to produce 24,000 times less of it in order to get the same warming, which is great.
At present, C3F8 is used as a cleaning agent for such things as liquid crystal displays and semiconductors. Its efficacy as a greenhouse gas is astonishing. If it could form even 1/6 millionth of the Martian atmosphere, it would raise temperatures by 30 degrees. A big result for a small amount.
And they're also not toxic to animals or humans. So let's say in the future, if you wanted to breathe that air, it would not have any toxic effects to anything living on Mars. Really, the key part here is that all of the elements that are required for making these gases are available on Mars.
C3F8 is comprised of carbon and fluorine. These elements are present on Mars. There would be no need to transport them all the way from Earth.
And I think once people start going, the whole process will proceed very quickly. It's like building a bridge across a river. Very difficult to put the bridge in, but once it's in, everything moves very fast.
In the early stages of terraforming, the atmosphere would still be very thin, and the Martian sunset will still seem quite fantastic. The current blue sunset on Mars. It looks blue because of the plentiful dust strewn about in the thin atmosphere. It's thought that the Martian dust scatters the longer wavelength red light, letting the blue light reach our eyes. As terraforming proceeds, the atmosphere will grow thicker, and Mars will have red sunsets like those on Earth. It's 2050, 15 years since terraforming commenced on Mars. Thanks to the super greenhouse gas C3F8, the average temperature has risen by 5 degrees. Now it's only -50. At this point, a small-scale facility would be built for long-term stays. The live-in staff would now number 20. They would run a plant pumping super greenhouse gases into the Martian atmosphere. But things would not always go according to plan. The Martian climate occasionally gives rise to unanticipated phenomena. This is an image taken by the Mars Reconnaissance Orbiter, high above the red planet. The white plume is a giant sandstorm called a dust devil. The largest ones reach a diameter of 70 meters and a height of 20,000 meters. Dust devils are apt to arise in the Martian spring and summer, when surface temperatures exceed those of the surrounding atmosphere. With wind speeds exceeding 100 meters per second, these are ferocious tempests indeed. The dust and sand they spray about can cover a facility's solar panels, resulting in power shortages. Ironically, the fine particles swirling around can generate electricity where it is not wanted. A direct hit from one of these dust devils can cause worse damage than expected to a facility. Resources needed for repairs might have to be shipped specially from Earth. If they were too late in arriving, or if some mishap occurred, survival on Mars could be threatened. For terraforming to proceed on plan, it is important to secure the necessary resources on site. Chris McKay believes that this problem is surmountable using a certain cutting-edge technology.
I think synthetic biology is going to play an important role in terraforming.
The Sonoran Desert straddles the border between Mexico and the United States. Here, a specialist in synthetic biology has been conducting research.
Okay.
Samples of desert soil are being collected by Ivan Paulino Lima. What does this have to do with Mars?
Well, in the United States, it's an area that is closer to the equator, so the UV levels tends to be higher here. So they need to cope with these high levels of UV.
Paulino Lima takes the Earth samples to the leading facility for astrobiological studies, NASA's Ames Research Center.
Good morning.
Good morning.
Here, there's a team researching terrestrial organisms that can survive in extraterrestrial conditions. Their current research focus is on how to produce certain microorganisms artificially and deliver them to Mars. They will be indispensable to the terraforming of Mars. From soil samples, the researchers select those microorganisms that are particularly resistant to the sun's UV rays. Then they extract their genes.
So breaking the cell membrane of these organisms and with different stabilizers, and so in the end we will have a clear solution with DNA that we can use for several purposes.
The solution contains the genes of the microorganisms that are resistant to UV rays. Next, they take those genes and mix them with laboratory strain E. coli bacteria. And then they zap it with 1800 volts. This high voltage surge opens holes in the surface of the E. coli bacteria through which the extracted genes enter. That creates a strain of E. coli with superior UV resistance. Introducing foreign genes to produce a new organism with desired characteristics. That's synthetic biology. Here, the research is on organisms that can help secure the food supply on Mars.
So this is the Anabina here. This is the engineered one with the sugar pore. There is carbon dioxide in this tube here, and with the light energy, it's creating sugar. It fixes the carbon dioxide from the gas and creates the sugar molecule. It's sucrose, which is what you get on your table. So what you add to food is sucrose, and that's what this is creating here.
Anabina is a vegetable plankton that lives in ponds and lakes. It stores up in its cells sugar made by photosynthesis. Hitherto, we have had no way to extract the sugar without damaging the cells. But researchers have suggested introducing a gene for holes in the cell membrane, making it easy to extract the sugar.
Grow it when you get to the moon or Mars or wherever you're going, and then you have a sugar production, basically machine, that you can grow and make sugar almost infinitely.
The plan is to send a load of Anabina into space in 2016. It will be a test to see whether or not sugar can be produced extraterrestrially. Synthetic biology is a brand new field. Some of its applications, however, are ready for actual implementation. Scientists here are cultivating a microorganism into which the genes of another creature have been injected. Those of a spider. The spider's thread has the strength of steel wire, but the elasticity of nylon. Scientists have hitherto been unable to reproduce it artificially. Now, synthetic biology is making that possible. The spider gene-fortified microorganism makes a protein that serves as raw material for the thread. This has enabled the successful manufacture of a new artificial material based on spider thread.
本当に衝撃に対して強いということですから、例えば宇宙で生活する時の、衣服だったり、じゃあ宇宙服の例えば、素材の一部に例えば使えるかもしれないですし、本当に先端分野の、いろんなアプリケーションに対して応用していける可能性っていうのは本当にたくさんあるんじゃないのかなと思っています。
The number of factories on Mars using synthetic biology to produce raw materials will increase. Terraforming will accelerate. The average surface temperature will rise to minus 35 degrees Celsius. At this point, the dry ice covering the polar caps will vaporize. And something long desired will appear. Water. Near the equator, there will be many days in a row in which the temperature will rise to plus 20 degrees Celsius. The ice hidden below the surface will melt. The water will pool, forming rivers and lowland lakes. Terraforming can now proceed to the next stage. (2060), the 25th year of terraforming. Mars is being transformed according to plan. But then,
what happened?
The air conditioner is blown. It's gonna take a while to figure out. I don't know why. Let's go. Come on.
Commander, take a look at this!
Huh? What is this?
it's a microorganism that has multiplied with great rapidity. If it starts reproducing inside the life support systems, human life could be threatened. At least one scientist is warning about depending on synthetic biology. Margaret Race studies the effects that advanced technologies have on life forms.
Synthetic biology is undergoing those questions now on Earth because we don't have the widespread use of it yet. It's still in the laboratory. And we're looking for all the places that something could go wrong. Let's think about it before we act. Let's think about it before we put things outdoors deliberately to let them evolve or mutate or perhaps die, so that we make wise decisions and avoid problems ahead of time.
In 1991, an extraordinary experiment was launched in the United States. Biosphere 2, an artificial habitat designed to test how, in the future, humans might be able to live in highly constrained circumstances in outer space. In the desert, a glass-enclosed space was constructed, covering as much area as 2 soccer fields. Some 3,800 types of animals and plants were brought in. Forest and ocean environments were artificially created. Water and air were circulated in a space cut off entirely from the outside world. The goal was to have 8 people survive in this closed ecosystem in 2-year rotations. But after the first 2 years, the experiment was shut down. All sorts of problems had arisen, from food shortages to worsening interpersonal relations. A major problem was the diminishing amount of oxygen inside the facility. There was one culprit: microbes. The organic matter in the soil used in the facility nourished a population explosion of microorganisms. That led to a reduction in the oxygen level. And it was not only microbes. Insects, including cockroaches, also reproduced rapidly. The lesson learned was that once things get out of control, such creatures can pose a threat to humans. What if the life forms sent to Mars evolved abnormally? That is precisely the subject of a sci-fi manga series called Terraforming Mars. The plot involves cockroaches and a special variety of moss. The surface of Mars is blackened, which absorbs sunlight, warming the planet. 500 years later, human beings visit Mars and find that they are under attack by cockroaches that have undergone a bizarre evolution. The terror of dealing with this unknown life form is thrillingly depicted, and the manga is very popular. The manga's creator is Yu Sasuga. He says the basic concept came to him when he heard about the terraforming of Mars.
火星にゴキブリを送るっていう話、その理論の話をどこかでやってたのを思い出しまして、もちろんその全く計算通りにはまずいかないと思うんですね。ただそれが環境に適応できるようになるとこういろいろと性質が変わっちゃったりっていうのはありえるのかな。どういうふうに変わるのかっていうのは全く想像がつかないですよね。
やっぱり遺伝子っていうのはその生命のプログラムで、その DNA 配列っていうのを書き換えてあげると、その良くも悪くもなってしまう。つまり人類に役立つような生命も作ることができれば、逆に言えばその人類をこう死に至らしめるようなものも作れてしまうわけなんですね。そういう意味ではこれまでの自然にこう進化してきた要は枝にこう突然変な枝を加えてしまうということにもなりかねないので、それは絶対起きないように心がけています。
Artificial resource production, environmental modification. That is the promise of synthetic biology. A great ethical debate lies ahead. It's 2075, the 40th year since terraforming began. The average temperature on Mars has risen 25 degrees to minus 30 degrees Celsius. With the increase in carbon dioxide, the atmosphere has thickened. The blue sky resembles Earth's, and clouds have started to appear. Near the equator, there are now over 300 days a year in which the daytime temperature exceeds 20 degrees Celsius. Large volumes of water well up from underground. In low-lying areas such as the Utopia Plain in the north or the Hellas Basin in the south, oceans will have begun to appear. And in the higher elevations, there will be snow. Falling snow is proof that water, evaporating from the oceans, has begun to circulate in the atmosphere. The snow colors the red planet white. In another 30 years, the Martian environment gradually comes to resemble that of Earth. By 2105, the 70th year since terraforming began, a town has been built on Mars housing 1,000 people. In addition to immigrants from Earth, there will be people who have been born and raised on Mars. It is believed that Mars was once covered with oceans. Thanks to human intervention, they have been revived. They stretch as far as the eye can see. Most of the northern hemisphere will be ocean. A great landmass will spread across the southern hemisphere. Atmospheric pressure at the Martian surface will be 300 hectopascals, or 0.3 atmospheres in terrestrial terms. That's 1/3 of Earth's, at the low edge of the pressure envelope within which humans can survive. Then, the historic moment. Liberation, at long last, from heavy spacesuits. Except for gear to supply oxygen, the air will still be 90% carbon dioxide. Finally, the climax of terraforming. Chris McKay and his group are thinking of importing plants and fungi from Earth to increase oxygen levels.
This could be the first, yeah. And the next, we could imagine something like this, like a moss. They utilize sunlight more efficiency than anything on Earth has. Then you could imagine making oxygen-rich atmosphere much, much quicker.
It is expected that mosses are so hardy that they will do well despite the adverse conditions on Mars. The barren Martian landscape will be transformed into rich soil. The next transplants will be alpine plants, whose flowers can bloom even in low atmospheric pressure. McKay also envisages sending over a certain insect indispensable to the plant's pollination. He has already conducted tests to see if this insect can survive on Mars. The honeybee. At how low a pressure and with how little oxygen can honeybees survive?
200?
Gradually, the air is removed and the pressure drops to 258 hectopascals, as low as at the summit of Mount Everest, about 0.25 atmospheres.
They're moving, but clearly they're not in as good a shape as they are at atmospheric pressure. To 1/5 of an atmosphere, and still the insects are capable of moving around. If one really wanted to develop bees that could survive at low pressure and could pollinate plants in a low pressure greenhouse or on a Mars with a lower atmospheric pressure.
Thanks to such insects, the alpine plants on Mars will increase their habitat range. The year 2135 will be the 100th year since terraforming began. Grassy plains will spread over the land surface of Mars. The average temperature will be 5 degrees Celsius. That's an increase of 60 degrees Celsius in just 100 years. The climate can now sustain larger types of vegetation. At this stage, it will be conifers that are planted. Conifers can grow steadily even in cold ground. Eventually, these saplings will grow into huge trees and form forests.
Maybe it's not very impressive life, but it's life. It is terraformed. It is like Earth, terraformed, because the important feature of Earth is life. Mars has life. It's terraformed.
In just 100 years, the terraforming of Mars, once merely a dream, has become a reality, a grand testament to human endeavor. Subsequently, the population of Mars will exceed 10,000. Humanity will be en route to building a new civilization. Mars will have been reborn as another Earth. Terraforming calls on a broad range of technologies. They are related also to a restoration of the Earth's own environment and the maintenance of a thriving ecosystem here as well. In the distant future, human beings may even shoot out of our solar system to build civilizations far, far away. Terraforming, a process that will constitute a great step forward in allowing terrestrial life to flourish forever in outer space.